So this is our third quadratic formula problem. So the steps are always the same. The difference in problems, remember the first one, it had a perfect square root. The second one, the square root couldn't simplify. This one, the square root is going to simplify. So I'll show you what happens then. But as always, steps are the same. First step always, get it in standard form. So that means it equals 0. And this one already does. So we're done with that step. Next step is to name the a, b, and c. So if I'm doing that for this problem, remember it's ax squared plus bx plus c equals 0. So my a this time is the number in front of the z squared. So there's nothing in front of there, so that means there's an invisible 1. My b is the number in front of the z. So this time it is a -6. And my c is the constant. This time it is a -1. Okay, our next step, as always, is to plug and chug in the quadratic formula. Okay, and you can have that memorized. You can Google it. You can look at page 58 of your notes. It is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if I'm going ahead and plugging and chugging in there, I start with x equals the opposite of b, and b this time is -6, plus or minus the square root of b, which is -6 squared, minus 4 times my a, which is 1, times c, which is -1, all over 2 times a, which is 1. And I always like to double check. So my a should be in two places, by the 4 and by the 2. 4 and 2 both have a 1. My b should be in two places, the first two spots, so -6 and -6. And my c should be in one place. It's at the end of the radical, and I have it in the right spot. I always check this because if you make a mistake early on, it's easier to check it, fix it now, as opposed to doing the whole problem and then realizing it at the end. Okay, so we always simplify in three places: front, under the radical, and underneath the whole thing. So I'm going to do those three simplifications right now. So I got x equals the opposite of -6, which is +6, plus or minus the square root. Now this is where I pull up Desmos and I type that whole thing into Desmos. Remember, leave the square root off when you're typing it in. So we've got -6 squared minus 4 times 1 times -1. So I've got 40. A really common mistake people make is they forget to put this parenthesis, and look, they got a whole different answer. So the parentheses matter for this one, and you'll get a +40. Okay, and then underneath it's 2 times 1, which is 2. Okay, our next step is to take this square root of 40 and to simplify it off to the side. So off to the side, we're going to simplify square root of 40. Okay, so we need to find the biggest perfect square that can fit into 40. And if you're looking at this, you probably already know what the biggest perfect square that can fit into it. But well, let's go on the assumption that you don't right now. So we would list them all. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Oh, we could stop because this is bigger than our square root. Okay, and we know 49 is too big, so it's going to be out. Now, just looking at this, I'm going to guess that 4 is my biggest, but let's check it to see if I'm right. So 40 divided by 36. Nope, that's decimal, so it's out. And I got to divide it by 25, decimal, 16, decimal, and 9, decimal. And then finally, when I do 4, ta-da, I was correct. So I could rewrite this as the square root of 4 times the square root of 10, because 4 times 10 make 40. Now I need to simplify my square root of 4. I bet you already know what square root of 4 is, but just in case you don't, it is 2. And because 10's not on this list, we're just going to leave 10 there. So I'm going to plug this back in. So I've got 6, x equals 6 plus or minus 2 square root of 10 over 2. Now, my final answer has to have that square root of 10 in it because it can't come out of the square root anyway. But I could still simplify my problem. I can look at the numbers that are not under the square roots and see, can I take anything out of them? So 6, 2, and 2. I think I could simplify that by dividing out a 2 on all of them. So when I do that, I get x is equal to 3 plus or minus 2 divided by 2 is 1, square root of 10 over 2 divided by 2, which is 1. And I could even take it one step further, and I could get rid of the 1s. I can make this one invisible, this one invisible, and I can make that one invisible. So it would be 3 plus or minus square root of 10. And I can even show you that right here on Desmos. If I were to put in 3 plus 1 square root of 10 over 1, and 3 minus 1 square root of 10, all divided by 1, I would get the same thing as just 3 plus square root of 10 and 3 minus square root of 10. You see how that's 6.16 and 6.16? And I got negative 0.16 and negative 0.16. So those 1s can totally go invisible and you're fine. Okay. So if I'm typing this into Desmos, remember Desmos does not like when you type in x equals. So I would just type in the 3 plus or minus square root of 10. Delta Math will take the 1s with it if you want to put the invisible ones, but you don't need them.